In the last segment, we saw how modern medicinal scanning is at its most basic a function of energy events that are happening at the nuclear level. In this segment, we're going to talk about how we harness nuclear power. Okay? Now, in addition to having tracers or some kind of medicinal visual application, nuclear changes involves a change in energy, which can be useful for commercial energy sources. This is how we get some electricity, for example. Now, your basic fission model says you have a heavy nucleus, such as uranium-235, that you hit with a neutron. That neutron will cause this to break up into fission fragments, and we get energy from that. Then, in addition to the fission fragments, we get even more neutrons. So we put one neutron into it, we get 3 neutrons out. And we get these fragments that themselves oftentimes are also radioactive. So this would be sort of analogous to the slot machines in, let's say, Las Vegas. Let's say every time you put a dollar coin in, you get 3 coins out. Well, you might think that sounds really great until your 3 becomes 9, which becomes 27, which starts to snowball, and you can't get it to stop. And what starts out as something wonderful becomes something that becomes very problematic. And my best example here is King Midas. King Midas is a fable of a king who wanted everything that he touched to turn to gold. And that was great and well and good and all, except when he started touching the people that he loved, like his child, she turned to a statue of gold. So a little bit is great, too much is like a runaway train. And this is what we call a chain reaction. Okay? Chain reaction. We create more products than what we put into it. And that in part is what makes fission reactions or nuclear power plants difficult to control and why they have sort of a bad reputation. Page 12. Let's move into fusion. In fusion, we're going to take 2 hydrogen nuclei. Okay, here's the hydrogen 2, here's the hydrogen 3. And we're going to fuse them together to make helium. In the process, we're going to give off energy and we're going to give off 1 neutron. Okay? Now, in the grand scheme of things, when you look at potential radioactive waste, okay, you've got these fission fragments that are themselves radioactive and have their own very lengthy half-lives, or you have what looks like kind of an innocuous event of 2 small nuclei of hydrogen fusing to form helium. Okay? Well, the problem is, where does fusion occur? Well, fission, as we've seen, occurs in nuclear power plants or nuclear bombs. Fusion occurs only on the sun. Okay? And while there are some efforts at something that we call cold fusion, the reality of it is even cold fusion is really too hot for what we can withstand and achieve on this planet. Nuclear power plants, nuclear bombs. sun. Okay? So the advantage of fission is that it's doable. We can actually do it. It's achievable. We can do this on the planet Earth. The disadvantage is that it's a chain reaction, difficult to control, radioactive waste. Okay, fusion is what I'll call clean. Okay, who doesn't love helium, right? But the disadvantage is that it only occurs on the sun. Okay, which means that if we want to take advantage of fusion, we have to harness, and make use of solar energy. Okay? On the next segment, we will do our $1.98 introduction to organic chemistry.